All right, so this is going to be a quiz review for the derivatives quiz coming up. So I'm going to break it into parts, hopefully intelligently labeled somewhere. This first part is going to concern from the limit derivatives from the limit definition. So if you're going to do what I'm about to show you, you want to look for this specific direction from the limit definition. And if you don't see these words, you will never do what I'm about to do, okay? But when you see these words, you must do it exactly like I do it. So I'm going to say, let's say I have f of x equals, let's do x fourth minus x squared, okay? So I have some little tricks to it. So you have to start with limit as h approaches 0. Make sure you have the limit statement and make sure you're consistent with it. F of x plus h minus f of x over h. So then, maybe start by writing and keep that limit statement on, because you will lose points if you don't, just writing the function with the x plus h in it. So remember, you've got two terms here, so we got to make sure we get them both in there. And then, this is just the f of x plus h part, f of x plus h. So then I need the f of x part, which is going to need to go in parentheses. It's always safe to put that in parentheses. There we go. And that's the f of x part, right? There are certain cases where you won't need parentheses, but in a lot of cases you will. So, let's err on the side of caution. All right, so then that equals limit as h approaches 0. So the next thing to do is expand your numerator. When you expand your numerator, don't just write a certain part here and a certain part here and then stick it all together at the end. Write complete, consistent statements. Have I mentioned that before? I think I have. All right, use Pascal's triangle to expand x plus h to the fourth power. All right, so Pascal's triangle goes 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. That's third power. 1, 4, 6, 4, 1. This is what we're going to use for that. All right, and then remember the powers of x are going to go down, the powers of h are going to go up. So we're going to go x fourth plus 4x cubed h plus 6x squared h squared plus 4 xh cubed plus h fourth, okay? That's just this guy, all right? And then I have to have minus the x plus h squared, so that means that's going to have to go in parentheses. So, and then when I expand that, I can also use Pascal's triangle 1, 2, 1. But you can also just say, oh, I know how to do x plus h squared. It's x squared plus 2xh plus h squared. Oh my goodness, I've run to the end of the page. What am I going to do? I'm going to put this all over h, but I'm going to continue it on the line below my minus x fourth minus x squared. All right. So I'm not going to put, so basically you can see that this is a continuation of the line above. That's how, certain computer programs, for example, will split up a long line like that. All right, so then I'm going to say that equals, keeping my equal sign, keeping my limit as h approaches 0. I probably should put this over here, then that would have helped me fit it on the page better. You can just right away immediately observe what's going to cancel, the x fourth minus the x fourth, the minus x squared plus x squared. Or you can do that in a separate step. So I'm going to just cancel those. 4x cubed h plus 6x squared h squared plus 4x h cubed plus h fourth. The minus x squared cancels, so I have minus 2xh minus h squared, being careful to distribute the minus sign here. All right, and then my denominator is h. An important check on this step, check it, make sure every term in the numerator has an h in it. It has to. If it doesn't, you did something wrong, so go back and fix it. So then this is limit as h approaches 0. Now we'll reduce the h out. You can show in a separate step factoring out the h and then reducing it, but you don't have to. I'm going to just go ahead and reduce the h. 4x cubed plus 6x squared h plus 4x h squared plus h fourth minus 2x minus h, right? It's nice if you put that in parentheses. It's actually technically necessary to put in parentheses. However, a lot of people won't, which is fine. Then in your next line, now you're going to evaluate the limit. So we're substituting the 0 in here. So for my 4x cubed, I'm going to have 4x cubed. It's nice if you put all these being 0. You don't have to write this, but it's nice, right? Because it shows why those things disappear. But you could skip this step and just jump straight to 4x cubed minus 2x. All right, and then I would recommend that you check your result using the power rule. So, your check using the power rule is that if f of x equals x fourth minus x squared, then f prime of x equals 4x cubed minus 2x. This is how you would do it if it did not say from the limit definition, but it does say from the limit definition, so we need to show all of this clearly, coherently, completely, and legibly. And this is just checking your work to make sure it's right. Okay, so what are some of the key features? You do not have to write this step, but it's nice. You have to write this. You have to expand it. You have to show how it simplifies step by step, keeping the limit, limit. When we evaluate the limit sign goes away. And it's a point to make sure that you have the limit where it goes and don't have the limit where it doesn't go. Okay, and then that's your answer. All right, so that is finding a derivative from the limit definition. And next we'll look at tangent and normal lines, I think.